Assalamu alaikum, dear students. Today's topic is applications of trigonometry. This is about how we use the basic concepts of trigonometry to solve the problems in daily life. Before going to the actual topic, we revise the basic trigonometric ratios. We suppose a right angled triangle ABC here. The side opposite to the right angle is hypotenuse, which is the biggest side. Then, if we work on the angle A, opposite to this angle is the side which is known as opposite, and this side AB would work as the adjacent, the side between angle under discussion and the right angle. This is adjacent. Now, the trigonometric ratios we revise to do further working on the applications of trigonometry. The ratio between the opposite and hypotenuse is known as sine of the angle. So, sine of angle A is equal to opposite over hypotenuse. Then the ratio between the adjacent and hypotenuse is the cosine of the angle A. So cos of angle A equal to adjacent over hypotenuse. Third ratio is the ratio between the opposite and adjacent of in a right angle triangle. Opposite to the adjacent is the ratio which is named as tan. So tangent of the angle A is equal to opposite over adjacent. Now we solve some basic questions using the trigonometric ratios. We take question 1 of exercise 7a from book 4. Li Ting, standing at P, is flying a kite attached to a string of length 140 meters. The angle of elevation of the kite K from her hand is 58 degree. Assuming that the string is taut, determine the vertical distance between her hand and the kite. Here, this is the figure. Over here, this is the kite. This is the position for Li Ting, who is flying the kite, and this one is the length of the uh, in this figure. Here is a right angled triangle PQK, where PK is the length of the string with what the kite is being flown. P is the position of the hand who is flying the kite. This KQ is the vertical distance of the hand from the kite we have to find out. So in this right angled triangle, 58 is the angle of elevation, which is angle under discussion right now. This is right angle. at the point Q. Now in this right angle triangle, to find out KQ, which is working as the opposite here, we'll use the trigonometric ratio. Yes, sine theta, sine of the angle 58. Sine 58 degree equal to KQ by 140. KQ we have to find out. We have found sine 58 degree using calculator. Now sine 58 degree 0.848 multiplied by 140 results the KQ, the vertical distance between the hand of the kite flyer and the kite. KQ results 118.7 meters, which is the vertical distance of the hand from the kite. Using trigonometric ratio, we have found the vertical distance between the hand and the kite. We take another statement of the simple one question. Question 2. The buildings on level ground are 120 meters and 85 meters tall respectively. The angle of elevation of the top of the taller building from the top of the shorter building is 33.9 degree. Find the distance between the two buildings. According to the statement, this is the figure drawn. This one is the smaller building having height 85 meters from the ground, and this one is the taller building which has the height 120 meters. Uh, this one would be the difference between these two. We'll find it out with the help of the difference between 120 and 85. It will give us the uh, opposite. Now, this distance we have to find out. In this triangle, it works as the adjacent. So, adjacent we are supposed to find out here. In this right angle triangle, to find out the distance between these two buildings, which I have abbreviated with D, the trigonometric ratio we will use tangent. Tan 33.9 degree is equal to 35 by D. This is how to find out the distance between two buildings D. Using trigonometry, we have found the distance between these two buildings, which is 52.1 meters, correct to three significant figures. It is better to discuss about the angle of depression before doing further. What is the angle of depression? Here is one exemplary figure. Let's suppose this is one short heighted boy which is observing this door from certain distance. Now his eye is at the same height as this handle is from the ground. So we take this blue line as uh, parallel to the ground. Now how much he observes from here at the bottom of the door, but the angle this makes here, this is the angle of depression, right? And how much he observes at the top of the same door, this would be the angle of elevation here. So angle of depression and the angle of elevation. Here is the statement of question number 4 of the same exercise. A building is 41 meters high. The angle of depression of a fire hydrant from the top of the building is 33 degree. Find the distance between the fire hydrant and the foot of the building. Now we solve it. Here is the figure for this solution. Over here, BC is the position of the building, and this is the position of fire hydrant, and the angle of depression is this one, which is discussed in the statement of the question. This 33 degree is the angle of depression of the fire hydrant from the top of the building, right? Now, at the point A, the angle BAC would also be of 33 degree. Why? Because of the alternate angles. Height of the building is given 41 meters. We are supposed to find out the distance of the fire hydrant from the uh, foot of the building, which is the distance AB. To find out this distance AB, we'll consider the triangle ABC, right? In the triangle ABC, tan of 33 equal to 41 by AB. This way, AB is equal to 63.1 meters, which is the required distance. If we take another question of the same nature, question number 5, a boat is 65.7 meters away from the from the base of the cliff. The angle of depression of the boat from the top of the cliff is 28.9 degree. Find the height of the cliff. According to the statement, we have drawn a figure. Over here in the figure, this is the distance between the boat and the cliff. This is the position of the cliff and this is the position of the boat. This distance is given to us, and the angle of depression from the top of the cliff to the boat is this one, 28.9 degree. As this is 28.9 degree, this angle at the point B should also be of the same degree. Why? Because of the alternate angles. Now in triangle ABC, we apply the trigonometric ratio tan 28.9 degree. You know, tan ratio is equal to the base, perpendicular over the base, means opposite over adjacent. In this triangle ABC, tan 28.9 degree is equal to the height by 65.7. Now we find out the value of this height. H would be equal to 65.7 multiplied by tan 28.9 degree. So H is equal to 36.3 meters, to three significant figures, which is the required height here in this question. We take another question from the same exercise. The statement of the question is, a castle has a height of 218 meters. A bird stands on level ground 85 meters away from the foot of the castle. Calculate the angle of depression of the bird from the top of the castle. Over here, this is the height of the castle, which is given as 218 meters. And this is the distance between the foot of the castle and the bird. We have to take this foot exactly beneath the top of the castle, right? It is the figure according to the statement, and we are supposed to find out the angle theta, which is the required angle of depression of the top of castle from the position of the bird. In this right angled triangle, on this position, on this point, it should also be of the same degree as this one is. Why? Because of the alternate angles. Now we consider this triangle, this right angled triangle, and apply the trigonometric ratio. What works here is tan theta. You know the trigonometric ratio tan theta is equal to the perpendicular by base, means opposite over adjacent. Uh, it would be 218 by 85, 218 meters by 85 meters. Now we solve it. To find out the required angle, we'll take tan inverse both the sides. So theta we have calculated equal to 68.7 degree, which is required angle of depression, right? All the best. See you in the next lesson. Bye.